Hello, everyone. It's Phil Jones for Projector Reviews, and joining me is Veronica from Texas Instruments. So, Veronica, how are you?
I'm doing well, thank you. Glad to be here.
Yes. So today we're going to be talking about DLP, which happens to be the leader when it comes to imagers that are found in commercial as well as consumer projection systems, and how they partner with other companies that make things such as light sources to give you outstanding performance. Before we get started, we'd like to thank our sponsors, Murideo and AV Pro, for helping me put on this year's Fall Projection Summit, where we talk about all the things you need to design a great projection system. So, Veronica, can you talk a little bit about Texas Instruments and DLP Technology real quick?
Absolutely. Texas Instruments has been the leader in the DLP technology for projection for the past few decades, specifically when we talk about cinema, right? That's the first thing that comes to mind. But after that, we start seeing the DLP projection is being used throughout home and education as well. So we're seeing an expansion of the DLP technology into the consumer products as well as the industrial one too.
And that's true. It's amazing how many projectors that come through Projector Reviews that are equipped with DLP technology. And you're starting to see a lot more utilizing LED light sources, which is what we're going to be talking about today. In fact, over the last few months, we have actually reviewed several really good LED light source equipped DLP projectors that can be utilized in both business, these cool little portable from XGME, all the way into you're starting to see LED and DLP utilized in home theater applications. So like I said, there's different types of light sources that can be utilized with a projector. So can you talk a little bit about the differences between these different light sources? Like, for example, the old school one was a lamp. So can you talk a little bit about that?
Absolutely. Let's go back to basics here from a projection perspective, right? There's three different functions in a projector. You have your illumination source, you have your light modulator, and then you have your projection lenses and your electronics. So what we're talking about here is the illumination source. And there are three very common ones that you see. The first and foremost that you would remember would be lamp. After lamp, you have LED. And then after LED, you have the laser. And now each of these light sources come in different formats. I actually brought one of the lamps with me just to remind you what the lamp looks like. So these are the different light illumination sources that can exist. Now from there, we go on to the light modulator, right? And a light modulator can either be DLP or can also be 3 LCDs. And that's the beauty about these projections, right? You can mix and match these different light sources with these different types of modulators, right? Then the third aspect of the projector would be the electronics and the projection lenses. And this is where some of the fun starts and the consumer activities come through, right? This is when you can make the decisions whether you want whether you're long throw or UST or a fixed lens or offset or zoom. But these are the three main components of a projector. And really what we're talking about today is the partnership between LED as well as DLP.
When you use a lamp, explain how a lamp works with the DLP imager.
Yeah, and let's go ahead and bring it back out. So pretty much you have a lamp, which is your light source. And with this light, with this lamp, you also have the color wheel, which I have right here. So when you're using a DLP projector with a lamp, you will always have a color wheel in there, right? So you have the light shining to the color wheel turns, and therefore that's how you go ahead and get the color onto the screen. As we move into LED, both the lamp and the color wheel go away.
Now, that color wheel is not only if you use a lamp, it also happens when you use something like a blue laser. So the blue laser kind of replaces the lamp, but now you're adding a blue laser and a phosphor wheel to replace the lamp system, correct?
Right, that's correct.
Okay, but both of those systems require that color wheel. Are there some advantages to removing the color wheel from the system?
Oh, absolutely. The first thing that you think about of a wheel is that a wheel moves, right? So now you're removing the wheel, so you're removing parts that move. So you really are moving towards a full solid state systems where there are no moving parts. When you take the lamp away, you take the color wheel away. And if there's no color wheel, which means fewer moving parts on your projector, making it more reliable.
So you talked about the fact that there is the benefit of an LED over a lamp is the fact that the system is solid state, which also helps with maintenance because number one, you don't have to worry about reducing some moving parts, but also there's also the light source lasts longer, correct?
Oh, yes, they do. Lamps wear out over time and basically they start losing brightness and eventually they fail. And so you need to have this replaced. LEDs are good for the lifetime of the projector.
Yeah, because most of the ones that we do, you're starting like you see them rated for 25 to 30,000 hours. And if you're using it 8 hours a day, 7 days a week, that can be years upon years upon years. So now we're talking about the reliability of a flat panel TV. A lot of consumers, when they see a projector, they still remember the bulb thing, and they're really concerned about using it all the time because of the lifespan. But now because of this, it has the same life as a traditional flat panel TV, which as a consumer gives you peace of mind, and as in a professional application, it just makes it a lot easier, especially if it's hanging 25 feet up in a museum doing for a installation. You just don't have to worry about it.
Absolutely. And I think that's the accessibility that it gives you. Now you become more friendly to different scenarios and different applications. And the example you provided is a perfect one, right? But now you can really go up high in ceilings and you can also go in very constrained environments as well. You don't have to worry about reaching that projector to go ahead and change the lamp on it.
Exactly, and which means like you guys like you pointed out in when you in your notes about this thing about 360-degree placement. You don't have to just put it up there, and you can mount it pretty much any direction. You don't have to worry about blocking the access panel to replace the bulb, which is actually a great thing. Also, the eco-friendly thing is actually a good point too. Can you talk about that?
Yeah, when you think about lamps, you think about mercury many times, right? And you think about replacement as well. So imagine every time you're replacing a lamp, not only is there another electronic going into the trash, but there's also mercury going in there as well. So LED does not have that issue. Therefore, it's so eco-friendly to be able to use it. And think about it also, lamps can get pretty big. And so just from the sheer size, right, you'll have less electronics going on into our environment.
Actually, yeah. Can you do me a favor and hold up those two pieces? Because you can remember that if you look at the lamp, the size of the lamp, and then the size of the color wheel, a lot of times that takes up a tremendous amount of space. And you're starting to see really, really, really bright LED-based projectors that are incredibly compact because the size of those components are now much, much, much smaller. Yeah. Some other things we want to talk about too is ease of use. A lot of times when you fire up a bulb-based projector, they take a while to turn on and a while to turn off. And the reason why they take so long is because they're trying to preserve the life of the bulb. If you fire it up too fast or you turn it off too quickly, you reduce the lifespan of the bulb. And the nice thing about an LED light source or any kind of solid state light source is it's pretty much instant on and off. You don't have to worry about the warm up and cooling time, which is something that consumers are liking. And lastly, we did like a Panasonic LRZ35. It was a DLP RGB LED projector. And what was nice about it was everything is sealed. The optics, the light source, everything is sealed, which makes it completely filterless. So just like if you're having a flat panel, you don't think about changing the filter in your flat panel. So that's that, and then you get that same type of ease of use and peace of mind and low maintenance because this is a closed optical system, which you don't have to worry about dust and stuff getting into the system.
I was going to go there myself too. With dust also comes, there could be some decaying in the image as well, right? You get those speckles of dust in there, and then your image is not as clear. So not only do you not have dust, which is the maintenance aspect of it and the reliability, but also the image quality associated with that.
And that maintenance thing really starts to matter. If you have your projectors mounted way up in the air somewhere, having to worry about going up there and changing filters and changing bulbs is something that you just don't want to do, and you don't have to deal with that when you talk about something like an LED light source. There's also an improvement in picture quality. So can you talk a little bit about that as well?
Yeah, and there's a lot of things associated with the picture quality. And first of all, we're going to talk about the color itself, right? The LED has a definitely a more desirable color palette.
Mm-hmm.
And if we think about the visible light spectrum, it goes from blue, violet to red,
Mm-hmm.
and eventually, from engineering terms, what you say, you're going from about a 400 nanometer wavelength to a 700 nanometer wavelength.
Mm-hmm.
Now, with LED, you can control the color palette so much better because you have different color sources. This
Mm-hmm.
means you can precisely control what wavelength you get and thus what colors you're producing.
Mm-hmm.
Now, in contrast, when you think about the lamp emits a wide bandwidth of
Mm-hmm.
different colors that kind
Mm-hmm.
of average to that yellowish white that we
Mm-hmm.
see. And then you
Mm-hmm.
need to decompose this to the red, blue, and green channels. And they
Mm-hmm.
change over time. These colors change over time as, of course, the lamp decays.
Mm-hmm.
So therefore, LED gives you the more stability on that, but also gives you better control of the colors. Then
Exactly. And a lot of times to expand the color gamut on a bulb, you also need to utilize, you see a lot of color filters being utilized. And putting a color filter in front of a bulb actually reduces brightness. So a lot of times you'll see not only a better quality color, but also brighter colors, because you don't have to apply cinema filters and color filters to try to expand the color gamut.
Yeah, and this has to do a lot with color saturation, what you're referring to with the color gamut, right? So if you
Mhm.
think about LED can easily reproduce real life colors, and that goes back
Mhm.
to color gamut. And
Mhm.
the more accurate that you can reproduce what the creators of a content intended, the better that it will look, right? So the
Mhm.
reason that LED can easily do this is because it has more colors than other illumination sources. What do I mean by
Mhm.
that? If you look at the color gamut as defined by the standard,
Mhm.
basically what the standard says is you assign specific color coordinates to each color.
Mhm.
And then you ensure that the color is reproduced on one display, looks identical than in the other display being shown, right? You don't want to have different reds or different greens from the same source being displayed. So the color gamut standard for television broadcasting is the Rec 709, which is what you see here. And the color
Mhm.
gamut is depicted as a triangle that you see on an XY chromaticity diagram.
Mhm.
And basically, the larger the area inside the triangle, the more color standard is capable of displaying.
When you first used to see DLP LED, there were more of the pico-based ones, the little guys that were very compact, very efficient, and they worked really well, very long life. But now you're starting to see more high-powered RGB-based LED light sources that are found in these projectors like this Panasonic here, which can output a much larger amount of light. So now you're starting to see them utilized a lot more in classrooms and business applications, and even in home theater. So you get all the benefits of LED, but now with the additional brightness, you also get to utilize it in more applications. The other thing too that I want to ask you about is, when I see LED light sources, I always see them paired with DLP. You don't really see them utilized much with something like maybe an LCOS or a 3 LCD system. So can you talk about why you'll see LED light sources with DLP more often?
Yeah, so DLP technology is very friendly to all kinds of illumination sources.
Mhm.
And so this provides great flexibility in the architecture. So, DLP technology can truly work with a lamp as much as with an LED
Mhm.
and as much as with a laser as well.
Mhm.
The 3 LCD technology can certainly use ELD, but because the 3 LCD needs polarized light
Mhm.
and the LEDs are non-polarized, you have an extra step in between the illumination source and the light
Mhm.
modulator, right?
Mhm.
So you need to be able to convert this unpolarized light to polarized. So there's an
Mhm.
extra step in there that certainly can add some complex, some size, and some expenses to it. And with DLP, you don't have to worry about that, right? DLP
Mhm.
works with non-polarized light. So that means
Mhm.
it doesn't have to go through this extra step and this extra expense. And that's the main reason why you're seeing DLP projectors use LED quite a bit.
So Veronica, I'm starting to see, like I said, these LED light sources found in a wide range of projectors. Like for example, this unit here is a new ViewSonic home theater based LED projector that utilizes DLP, and I thought this sucker offered a lot of great performance at a amazing price point. Now, depending on the manufacturer, you guys offer different options when it comes to DLP technology or the DMD chips that you're utilizing, correct?
Yeah, we have a full family of DMD chipsets now that are available out to the market, and they go from 0.47 inches all the way up to our newest ones that were just recently released are 0.78 and 0.8 inches DMD devices. So certainly developing a full family meant to be used with LED, designed for LED.
So let's talk a little bit about how an LED, a DMD imager works. So can you talk a little bit about it for those people who are not 100% familiar?
Yeah, so basically the mirrors within the DMD are the ones that go ahead and project the light into the screen. And we have this effect called XPR, which is your extended pixel resolution that allows you to get different colors into the same pixel. So you're able to portray this image onto the screen quite quickly and quite efficiently, as well as with some very clear colors.
And DLP, DMD imagers are incredibly reliable, even though there's these little itty bitty mirrors, which I think you actually have one that you can actually show, right?
I do. I brought one with me. This is one of our latest DMDs that we have just released. It's a 0.78 DMD, and they are available to address 1080p, WXGA, and the 4K resolution.
Okay, and if you look at that, it's still incredibly compact. If you look at it compared to a 3 LCD or even a LCOS, the imager itself is much more compact, which means everything gets smaller. The box, the lenses, everything can be a little bit more compact.
And I also want to add one more thing in reference to that, and it's the added bonus, of course, of LED and the color and the maintenance as well. But there's a factor as well of efficiency into these new DMD devices that are being designed with LED. And these new DMD devices are being really designed to function with LEDs and to function efficiently. Now, what do we mean by this? With what we mean by this is a DMD is efficient or a projector is efficient when the heat dissipation turns into light instead of power, right? We don't want to have heat in those projectors. That's what drives it to have low maintenance, to have high maintenance, right? And to be able to break down. So what these DMDs are doing right now is they're very much more efficient. So you have more light coming into the DMD and more light gets into the screen. And so there are better colors, better contrast, lower heat dissipation, which means greater reliability. And this also means smaller systems. And this just all becomes so much more attractive to the consumer. So we need to also remember the efficiency also that these new DMDs bring together with LED.
Yes, I'm glad you brought that up because we're starting to also see, I reviewed a couple of really cool battery powered LED equipped projectors. LED equipped DLP projectors, and the batteries could last for hours, several hours. Now, and it was still very compact. Why? Because like I said, you're not wasting power heating up the box, and you can get a lot of light for the amount of wattage or battery capacity. So the majority of battery powered portable projectors that happen to be pretty bright, you're starting to see them now approaching 600 to 1,000 anti-lumens on a battery, and all of them utilize DLP with LED. So that's a really good example of efficiency, and you could take your projection system with you anywhere, and it's ultra compact and reliable, which I think is great. Okay, Veronica, so we're talking about this, the imager has millions and millions of little individual mirrors. So you can have like maybe 8.8 million, it can have maybe 2.2 million. But the amount of mirrors that are on the DMD does not dictate the displayed resolution on screen, correct?
Yeah, and you can have both options, right? You can have some of them, like you said, that have 2 million mirrors on the DMD itself, and you're displaying into a 4K UHD, right? And that's because TI DLP technology has an XPR technology that allows us to do this. And basically, what this happens is you can have 4 different color pixels in one same mirror, and they move so fast that you're able to display that 4K UHD.
Yeah, because I've seen some large commercial pieces with 8.8 million. I've seen some small pieces, like maybe something that has like a little 0.47 that's small, found in a smaller 4K consumer-based one, but the resolution on screen is still 8.8 million. And because this is kind of a topic that happens all the time on our website. People say, well, is it truly 4K that I'm seeing? And the answer is yes. When they say you're seeing 4K, you are seeing 4K. The mirrors are moving so fast and writing 4 pixels, like even if it's writing 4 pixels at a time, it's moving so fast you cannot tell you cannot see a difference between it being natively having 8.8 million pixels on the imager itself, or it versus seeing 8.8 million on the screen.
Yeah, and that goes back to the XPR that I was referring to earlier today, right? We have these mirrors that can switch back and forth, and they can move inside of this DMD and are able to give you 1, 2, 4 different pixels at a time. And therefore, the display that you get is a true 4K UHD display onto your system, and you can see it with a lot of clarity.
And you got to remember that with DLP, it's only showing you one color at a time. Shows you red, shows you blue, shows you green. So it's only showing you one color at a time, but it's moving so fast. You're seeing magentas and purples and all the different shades and the billions of colors that are available in the rainbow. So if you cannot tell that the imager is that this is showing you one color at a time, how are you going to be able to tell that one mirror is writing 4 pixels at a time? Another advantage of this is because you're using a single device instead of multiple devices like you would see in maybe a 3 LCD or a LCOS system that has 3 chips, you don't have to worry about convergence. And convergence is you have those 3 imagers and they have to be precisely aligned in order for the image to appear sharp. That's one less thing that you have to worry about. I have found a lot of times that if a 3 LCD or an LCOS is not perfectly converged, a single chip will look better and look sharper most of the time. So there's an advantage of it being a single chip generating all of the information. Integration between DLP technology and RGB LED light sources.
You know, the more activity that we're seeing is it's a lot of it in gaming, in screenless TVs, and then also in new applications such as warehouse automation and stage lighting as well. So we're definitely starting to see some new applications come up because of this and the abilities that it can do.
So as you can see, DLP with RGB LED is a match made in heaven. There's so many advantages of combining those two technologies together. And Veronica, thank you for coming and explaining the benefits of LED light sources with DLP.
It was my pleasure, and thank you so much for having us here and for your time.
To learn more about DLP and its benefits, check out ti.com/DLP. And also check out our latest reviews of LED-equipped DLP projectors on projectorreviews.com. So take care, everyone, and we will talk to you soon.